Welcome back to Nano Productions by Nano Learning. So this video, we're going to review magnetism. So, like I said in the last video, we will be going over magnetism. Well, apparently this video was necessary since magnetic potential energy is very important to know. Alright, so let's get to it. So what is magnetism? It is defined as the attractive and repulsive phenomenon produced by a moving electrical charge. An invisible force attracts and repels certain metals and more. Alright, so one thing I want to explain here immediately. This is a definition that you will find inside like a dictionary, which I actually got from, or an article. This is the simplest definition you can remember. This is something you want to remember, alright? So I will be pointing out some stuff that you might want to remember, because simplest is the best way to remember, right? You want to remember the easiest words possible. Alright, so attract or repel. Attract means to come together and connect, and repel means to push away. This image immediately shows that. Repel, not so well. And then attract, well, these are together, yay. Alright, friendship achieved. Alright, now you may notice, actually there's a really good concept. Blue and blue, why are they repelling and blue and red attract? Well, there's a very important concept that has to be covered here. So let's talk about magnetic field. So it's an area/region around the magnet where an object within that range can attract and repel. So some people consider the field where the magnetic strength continues, so it can attract and repel. The magnetic field can be affected by the size and the materials from which the magnet is made of. So, to give you a visual example, this is a magnet. Alright, so I am using a different piece of software. I feel like this is much simpler. Alright, so this is our magnet. Now, not very well coloring skills. I mean, that coloring doesn't matter, just for display. So you can differentiate everything. So here's our simple magnet, which I try to draw. Did try to work. Alright. So let's look at the magnetic field around this magnet. So this is one circular motion, which is a magnetic field. Alright, so let's just say this is just one part of the magnetic field. Well, we can extend past that. Alright, so this is a definite extend passing that could occur. So we can move on here. We can even move on even further. Alright. So it could be anywhere, trust me. Alright. So this is basically it. So let's just say I was to increase the size of something. So if I was to select that. Let's just say I was to have a bigger magnet. Alright, so this is your bigger magnet, alright? Now the magnetic field has just increased, alright? So we just gotta increase magnetic field. Alright, and probably a bigger magnetic field, alright? So we got a lot more stronger force at the end now. Now let's just say we were to take this further, and I was to get rid of that field, and let's just make it even larger. So look, we actually just got a pretty large magnetic field to the point where it's actually really strong at this point. It means the size of the magnet was affected, alright? That's the main concept I want you to take out of here. The size of our magnet was affected, alright? And apparently, if we were to really increase it, we actually get a really strong signal. A real strong field. Alright, so this might actually look like waves, which we'll be going over soon. So stay tuned. You'll learn all about waves. Alright, so let me just represent this. Alright, so and then the materials from which the magnet is made from. We will talk about materials in a later topic. So basically, what is it made of? If it's made of, so if it's something made of that's really magnetic, it will actually have a harder magnetic field. Alright? There's a lot to magnets. This is just the beginning. Alright? Just to understand magnetic potential energy, nothing else. So we have two poles of a magnet. So they have a north and a south pole. Alright? So let's talk about this concept. So let's draw a magnet just like this one. Yay. Time to fail. Alright, so there's one. Let's take that. Copy it over. Alright. So we can take our fill bucket tool. Actually, if you want to follow with this in the fun, sure, go ahead. Alright, so here's our magnet, alright? We could use a light blue. Blue is a lot better. So we have blue and red, right? Alright, so here's our magnet. Now, so let's talk about this. So we have two poles on a magnet, a north and a south. So I'm going to change colors. So according to this, so I'm going to just follow this picture. So this is the north pole. According to the picture, actually it doesn't matter what color, because in reality there's no color in magnets. And south. Alright, so you remember the blue as being south, north is red, but even though the colors have no coordination, alright? So once again, the colors have no coordination. And to display that for you, it can be orange. Alright, so no coordination whatsoever. Now, one thing here, if you cut a magnet in half, the pieces made will each have a north and a south pole. Alright? So let me display that. Let's just say I was to cut a magnet in half. So let me just draw a very basic magnet. And let's just say we have a north pole and a south pole. Alright, and let's just say I was to cut this. Alright? So when I cut this, alright? So when I go ahead and cut this, alright, let me just do something. I just want to have a better demonstration of it. So I'm going to replace these north and south poles. So this is our north pole to make it more efficient. And this is our south pole. Alright, so let's just look at it this way. When I cut this, let's see what I end up with. So my end result should be two magnets, right? So hopefully it is two magnets. Alright, now let's look at them. So let me show you. Now let's observe the results here. Now both of them got a north and a south pole. So the most expected, so the best answer would be that one side will have a north and the other will have a south, right? Now that's the most thing, right? The most expected thing is that probably these will have a north and south pole. If they're both about like that. Now let's just say, which I did change earlier, that we put this stuff on the wrong sides, alright? So when I cut this, let's just put this on the north. So when this is cut, we are ended with two magnets again. We have a north, this thing has a south. But wait, this has a north. So does this have a south? So what is the deal here? That is because of this. Each of the magnets will have a north and a south pole, alright? So you just created two new magnets. We have gained two magnets here, alright? Just by dividing this. I could have divided this even like this and still gotten the same result, except just in a different format, right? Doesn't matter how you cut it. No matter what, magnets, they will end up like this, alright? A north and a south pole. So that is the basic concept here. So let's just represent, alright? So the two poles can repel and attract the different various magnets. Let's look at magnet behavior. North and south poles of a magnet attract, two north poles repel, so does the south pole, and when a magnet repels or attracts, it has potential energy. Alright. Alright, so let's just have a very nice magnet here. So this magnet is magnet 1, so it has north and a south pole. North, south. So this is magnet here. Alright, so once again, north, south. I'm going to take this. Alright, so let's just draw another set of magnets. So this will be the south pole. This will be the north pole. So this will also be this will be the north pole. So will this be the south pole? Alright, so what is the expected behavior between these two? Alright, so I'm expecting these to attract. Alright? Because they're opposite poles. And to make that more visual, that they're both opposite, that will not work. Alright, so we'll just forget that for now. So to make these opposites, so these will attract, but these are north and north. So they repel. Alright, so these just push against each other. So these will go a little further away from their original spots. Alright, so these will tuck away a little bit. But these attract. These are opposite poles. Same story for two norths. Alright? So I want to quickly get through this. We're out of time almost. And not much remaining. So let's do this to be the north pole. This could be the south. This could be the south. This is the north, alright? So these will also repel. Wait, they're the same poles. Alright, so let's just represent this quickly. So now, how do magnets function? Great, we're on the best slide of all. So, the north pole of a magnet is attracted to the Earth's north magnetic pole, so is the south, alright? This statement, I want to explain this something. Here's Earth. Welcome. This is north. This is south, alright? So we say that a compass, make their compass a different color. So let's just say that the magnet, actually, make the rectangle. The north pole is attracted to the north and to the south, alright? But if we're saying it's attracted, couldn't this be the south pole? Well, so we can say that the planet's pole, this is how it's shaped, because we want the north to attract the north, right? So if we want them to attract, don't they have to be the opposite? Alright? So that's how magnets basically function. They're attracted to the pole. So the north pole is basically our Earth planet's opposite pole, which is the north pole is the south pole is north pole. Alright, so remember this. This can be on any quiz or test. So organisms do use magnetism. So they have the ability to sense a magnetic field is called magnetoception. Now I did not study this very well. Alright? So I cannot really explain this, but I'm pretty sure a quick Google search on this will give you a good idea. And by the way, let's just let you guys explore this topic. Alright. So let me talk about joining our Google Classroom. So please join our Google Classroom for a lot of course content. So I will just go to classroom.google.com. And there'll be an I agree statement, just press it. And you want to click on join class right here. Alright, you just need a free Google account. If you have a Google account, it's probably the one you use for Gmail. You just copy this code. You paste it here and you can join, alright? So, and you just press join and then you'll get all my class content and everything. It's totally free, so why not? Why give up free stuff? Alright, so in the next episode of Nano Productions, we will go over some topic, which will be lesson 3.6. So it is planned to be calculating potential energy more practice. So you will see me more on the whiteboard. Alright, thank you for watching Nano Productions, and I want the comment section to be full of discussion.